Hi, welcome to Expertise Academy. This is Giri, lecturer in physics. In this video, we'll discuss about the conservation of energy in Lc oscillations. Conservation of energy. So, what is the meaning of the conservation of energy? In general form, there is no creation of energy as well as destroying of energy, but energy is transferred from one form to another form. Energy is transferred from one form to another form. Okay, let's verify this. During Lc oscillations in Lc circuit. So Lc circuit means the circuit which contains the inductor and capacitor. So here these two things, inductor and capacitor, connects with the AC voltage source. In this AC voltage source, the current is developed or current is released. It is passing through inductor and capacitor. At inductor, magnetic field is generates. At capacitor, electric field is generates. Here, energy is moving from capacitor to inductor, or magnetic field to electric field. So magnetic field is generates at inductor, electric field is generates at capacitor. The energy of the system oscillates between electric field of capacitor and the magnetic field of the inductor. Although these two forms of energy vary with time, the total energy remains constant. The two forms of energy is varying with time, but the value is constant. It means that Lc oscillations takes place in accordance with the law of conservation of energy. It means that Lc oscillations takes place in accordance with the law of conservation of energy. So let's verify this. Total energy U is equal to energy in capacitor, that means energy for electric field, energy at inductor, that means energy for magnetic field, that is equal to Q square by 2C plus half Li square. Let us consider three different stages of Lc oscillations and calculate the total energy of the system. So let us consider three different stages of Lc oscillations and calculate the total energy. So we have three different stages of Lc oscillations. Case 1. When the charge in the capacitor Q is equal to Qm, so that is maximum charge in the capacitor. The current through the inductor I is equal to 0. The total energy is given by. So when the charge is very maximum in the capacitor, the electric field is generates at capacitor, but at inductor the current is 0. That means the magnetic field value, that quantity is 0. There is no any magnetic field. So at this situation, The total circuit is purely capacitive, and this condition, the total energy U is equal to Q square by 2C. The total energy is wholly electrical. Next, case 3. Let's go for second case. When charge equal to 0, current I is equal to IM. The total energy is U is equal to half Li square. Half Li square. So here, the magnetic field at the inductor is generated, but electric field in capacitor is 0. U is equal to 0 plus half Lim square. So Im is the maximum current. That is equal to, in second case, the electric field at the capacitor is 0. So finally, we get the relation U is equal to half Lim square. So we know that Im is equal to Qm into omega. That is equal to omega is nothing but square root of 1 divided by square root of Lc. This is the resonance frequency. Resonance frequency. So substitute this relation in this equation. So that is equal to L by 2 into Qm square divided by Lc. L cancel. Qm square by 2c. The total energy is wholly magnetic. This is the second case. Now third case. When charge is equal to Q, current equal to I. Here, total energy is Q square by 2c plus Li square by 2. Since Q is equal to Qm cos omega t, I is equal to minus dq by dt. That is equal to Qm omega sin omega t. The negative sign in current indicates that in third case, the negative sign in the current indicates charge in capacitor decreases with time. So that is equal to Q square cos square omega t by 2c plus L omega square Q square sin square omega t by 2. So here Q square cos square omega t by 2c plus Lq square sin square omega t by 2Lc. Omega square is equal to 1 by Lc. So Q square by 2c into cos square omega t plus sin square omega t. So this is equal to 1. So here U is equal to Q square by 2c. From above these three cases, it is clear that total energy from these three cases, we observe the energy is equal to Q square by 2c. So that means the value of energy, the magnitude of energy, no change in three cases. In first case, the current at inductor is 0. The energy at inductor 0. In second case, the energy at capacitor is 0. In third case, there is a energy at two things, but here the energy value is same. So this is the information about the energy in LC oscillations. So thanks for watching this video.